Today, I've got a cool problem to share, and it's personal. A while ago, I was in an L1 interview for a data engineering job. The interviewer was super qualified, an IIT grad with multiple master's degrees, leading a big team. He asked me how many trailing zeros are in N Factorial. I panicked. I knew factorials partially as it's been so long, but figuring out the zeros without calculating the huge numbers, it was tough under pressure. I couldn't answer then, and it stuck with me. I was hoping SQL and Spark questions, as these were mostly asked before. This was my 13th interview in the past 4 months. But I didn't give up. I studied it at home, breaking down the math and coding it in Python. Now I'm here to explain it simply. Let's use this visual guide I made to make it easy. The key idea here is to figure out how many times 10 is a factor in N Factorial, because each 10 adds a trailing 0. Since 10 is 2 times 5, we need pairs of 2's and 5's in the prime factorization of N Factorial. Let's explore the cases. For case 1, if n is less than 5, the count is 0. Let's look at the factorial product. For n equals 1, it's 1, no zeros. For n equals 2, it's 2, no zeros. For n equals 3, it's 6, no zeros. For n equals 4, it's 24, again, no zeros. But when n equals 5, we get 120. We get our first 0 because 5 times 2 gives us a 10. So, if n is less than 5, there's no combination of 2 and 5 to make it 10. And the count stays 0. Now for case 2, if n is 5 or more, we use a while loop. The code initializes count to 0 and I to 5. Then it adds integer division, which is basically quotient from n divided by I to count. That's giving us the number of multiples of I, a power of 5 in n. For example, if n is 10 and I is 5, 10 divided by 5 is 2. The quotient is 2, meaning 2 multiples, basically 5 and 10. After that, I multiplies by 5 to check the next power, like 25 or 125. This process repeats until I exceeds n. This is how the division works. N divided by I gives a quotient and we add that quotient to our count. Let's walk through the code. First, we define the function def trailing zeros. This takes n as input, the number whose factorial we're analyzing. Inside, count equals 0 sets our counter to 0, then I equals 5 starts us at the first power of 5 since we are counting factors of 5. While loop that runs as long as I is less than or equal to n. Inside, count addition operator and equal operator with integer division of n and I. This adds the number of multiples of I to our count. Then I asterisk equals 5. This updates I to the next power of 5, like 25. Finally, the function returns count, giving us the total number of trailing zeros. Outside the function, n gets the user's input and converts it to an integer. Then, result calls and stores the function result. Lastly, print displays the answer. Let's test it with n equals 10. That's the full explanation. This method avoids calculating the factorial directly. If you enjoyed this breakdown, hit that like button drop a comment and subscribe for more. See you next time.